Blockchain technology has revolutionized how we think about data, trust, and value exchange in the digital world. At its core, a blockchain is a distributed ledger, a database spread across multiple computers or nodes that securely records transactions without needing a central authority to verify or approve them. This decentralized nature allows blockchain networks to function transparently, resiliently, and independently of any single party's control. Disclaimer: this content is for educational purposes only and does not constitute financial or investment advice. Always do your own research before making financial decisions. In a traditional database, records are stored in a centralized server, and an administrator controls who can read or modify them. But with blockchain, every participant on the network has a copy of the same ledger, and updates occur only when the majority agrees, creating a system of collective verification that is extremely difficult to manipulate or corrupt. A blockchain ledger organizes information in blocks that are chronologically linked, forming a continuous chain, hence the name. Each block contains a list of transactions or data entries, a timestamp, and a cryptographic hash of the previous block. This hash connects each block to its predecessor, creating an immutable record where altering any one block would break the entire chain's integrity. At the heart of blockchain security is cryptography. Transactions are verified using cryptographic algorithms that secure data and ensure authenticity. Public key cryptography allows each user to generate a pair of keys, a private key for signing transactions, and a public key that others can use to verify those signatures, ensuring only rightful owners can move or modify assets on the blockchain. Consensus mechanisms are the protocols that blockchain networks use to agree on the validity of new transactions. The most famous is proof of work, POW, used by Bitcoin, where miners compete to solve complex mathematical problems. The first to solve it earns the right to add a new block and receives a reward. This process consumes significant energy but provides strong security. Proof of stake, POS, is another popular consensus method that selects block validators based on the amount of cryptocurrency they have locked or staked in the network. This approach reduces energy consumption and encourages participants to act honestly, since misbehavior could mean losing their stake. A key feature of blockchain is decentralization, which distributes power among many participants instead of placing it in the hands of a few. Decentralization makes blockchains resistant to censorship, as no single party can alter records or block transactions unilaterally. This aspect has driven blockchain's popularity in financial, social, and governance systems. Transparency is another pillar of blockchain technology. Since transactions are recorded on a public ledger accessible to all network participants, anyone can audit the chain's history. This transparency builds trust and accountability, crucial in industries like finance, supply chain, and voting systems. Despite its transparency, blockchain can still provide privacy. Technologies like zero-knowledge proofs and privacy-focused blockchains, e.g. Monero, Zcash, allow users to prove they own assets or satisfy conditions without revealing sensitive information, balancing openness with confidentiality. Scalability has been one of blockchain's biggest challenges. As more users join the network and transactions grow, blockchains can face congestion, high fees, and slower processing times. Solutions like Layer 2 protocols, e.g. Lightning Network, sharding, and sidechains aim to increase throughput without compromising decentralization. Smart contracts are programs stored and executed on a blockchain that automatically carry out predefined actions when specific conditions are met. They enable trustless agreements without intermediaries, powering decentralized applications, dApps for finance, gaming, insurance, and more. Ethereum popularized smart contracts, allowing developers to create decentralized protocols and tokens directly on its blockchain. This flexibility laid the foundation for the explosion of DeFi, decentralized finance, and NFTs, non-fungible tokens, which rely on programmable blockchain assets. Mining is the process of validating and adding new transactions to a blockchain in proof-of-work systems. It involves solving complex cryptographic puzzles, which requires computational power and electricity. While mining secures the network, it has raised concerns about environmental impact. Nodes are individual computers running the blockchain's software, maintaining copies of the ledger and relaying information to other nodes. Full nodes keep complete histories of the blockchain, while light nodes only store recent data, enabling less resource-intensive participation. Forks occur when blockchain communities disagree on protocol changes, resulting in a split of the chain into two separate blockchains. Soft forks are backward-compatible changes, while hard forks create entirely new chains with different rules, as seen with Bitcoin Cash splitting from Bitcoin. Tokenization allows real-world assets, like art, real estate, or commodities, to be represented as digital tokens on a blockchain. This enables fractional ownership, easier transfers, and broader access to investments that were previously illiquid or inaccessible to many. Immutability means once data is recorded in a blockchain, it cannot be changed or deleted without altering all subsequent blocks and gaining control of the majority of the network, an almost impossible task on secure blockchains. This feature makes blockchain records highly reliable. Decentralized autonomous organizations, DAOs, are organizations governed by smart contracts and community voting without centralized leadership. Members propose and vote on changes, enabling collective decision-making for managing resources, projects, or protocols transparently. Blockchains can be public, like Bitcoin or Ethereum, where anyone can join and participate, or private/permissioned, where access is restricted to specific participants. Private blockchains are often used in enterprise settings for supply chain tracking, identity management, or interbank settlements. Oracles are services that connect blockchains with real-world data, feeding external information, like weather, sports results, or asset prices, into smart contracts so they can execute based on real events. Chainlink is a leading blockchain oracle provider enabling these connections. Interoperability is the ability of different blockchains to communicate and exchange information or assets seamlessly. Projects like Polkadot and Cosmos focus on creating ecosystems where multiple blockchains can operate together, breaking silos and expanding possibilities. Hashing is the process of converting data into a fixed-length string using a hash function, producing a unique fingerprint for that data. Even the smallest change in the input generates a drastically different hash, making it a crucial tool for blockchain integrity and security. Block time refers to the average time it takes to create a new block in a blockchain network. Bitcoin's block time is around 10 minutes, while Ethereum's is roughly 12 seconds. Block time affects transaction confirmation speed and the overall network throughput. Halving events occur in some blockchains, like Bitcoin, where the reward miners receive for adding new blocks is cut in half after a set number of blocks. Halving slow the rate of new coin issuance, controlling inflation, and often affecting price dynamics due to reduced supply growth. Blockchain explorers are online tools that allow anyone to view transactions, addresses, and blocks on a blockchain in real time. Explorers promote transparency by making it easy to audit activity on a network, ensuring no hidden transactions or manipulations. Cold storage refers to keeping cryptocurrency private keys offline, protecting them from hacking or malware. Hardware wallets, paper wallets, and air-gapped computers are common cold storage methods, providing maximum security for long-term holdings. Hot wallets, in contrast, are connected to the internet and allow convenient access to cryptocurrencies for frequent transactions. But they're more vulnerable to cyber attacks than cold storage solutions, highlighting the trade-off between security and usability. Gas fees are transaction fees paid to miners or validators for processing operations on blockchains like Ethereum. Fees fluctuate based on network demand and complexity of operations. High fees can deter small transactions, but incentivize network security. Layer 2 solutions operate on top of existing blockchains to process transactions off-chain or batch them before final settlement, increasing transaction speed and reducing fees. Examples include Lightning Network for Bitcoin and rollups for Ethereum. Consensus attacks, like the 51% attack, happen when a malicious actor gains majority control of a network's hash power or stake, allowing them to double spend coins or censor transactions. While theoretically possible, they're economically and logistically challenging on major blockchains. If you found this deep dive helpful, hit the like button, Subscribe for more cryptocurrency education and share this video with your friends so they can learn about blockchain too.